let's repeat the process now. So again, we have here now a box again. Now. This box now is placed on a table. And as we place it on the table, of course, the body there will have a weight. No? It will have a weight. And its weight, according to the problem, our previous problem, the weight is 600 Newton. No? Now, because of the weight of this object, no, then we will agree that there would be a reaction on the table. No? So the table eventually will push this up. We call this now as our normal force. So our normal force is going up. No? Now there's another force here. Now this time the force is acting at an angle. So this forms an angle, and the force that we will exert there, since that is moving away from the box, then that's a tension. No? We are to find how much is the tension here. No? If our box, no? If our cable or tension is acting at an angle equal to 30 degrees, no? How much should be the force that we will exert, no? So the angle here is 30 degrees. Now we said that if there's a force that acts na at a certain angle, then it must be no, that it forms no two components. No? So what are these components? Again, one horizontal component and another no, which is a vertical component. No? So we call basically the horizontal component as Tx. And T sub x is T cosine of the angle 30 degrees. While your T sub y, the vertical component, is equal to T, no, tension, sine of 30 degrees. No? So if you want to substitute the value 30 degrees there, no, then you may do so. No? Now, when we pull this to the right, what we discovered is that now this one will create a frictional force. The frictional force is just lesser than the tension, but it will be directed to the left side. No? This will be the direction of our kinetic frictional force. No? So we call it Fk. No? Now, there's a value here called mu, and mu no, is around. There's a mu value, and again, mu is due to, no? Our mu value is due to, again, sorry. No? So this is your F sub k. No? And on this side here, no? So maybe no, there's your coefficient of kinetic friction. Mu sub k ko na is 0.12. No? And again, our symbol for mu natin symbol, mu sub k. No? So our mu sub k, again, no, is a factor that is between 0 to 1, no? And it is due to the kind of surface that are in contact. No? Now, again, what we did was we divided the forces here in terms of those that acting on the horizontal axis. And the one that acts on the horizontal axis is T sub x. No? Now, how do we consider there the original tension T, no, of the original cable? No? Now, since we split this force into its component Tx and T sub y, we may as well, no, disregard this force as if it does not exist, because we now break it down into its components Tx and Ty. No? So in terms of Tx now goes right, while no, along the horizontal line, your Fk is going left. No? Now, if this is the one that causes motion and the motion there is uniform, then their total must be 0. No? Again, the reason is this one is moving no, with uniform velocity no, or uniform motion. No? So this is one set of equation. Now another set of equation is our vertical forces. And along the vertical axis, no, one force that goes up is N. Another force that goes up is T sub Y. No? So they are indicated with plus. And then we will subtract W no, since W is going downward. No? Now along the vertical axis, this body does not move actually. No? So therefore, we can also say that it is also equals to 0 because it is at rest vertically. No? So these are two sets of equations. No? Now from our first set, we can probably say that T sub x is equals to Fk. No? And if we replace our T sub x to be T, no? Cosine 30 degrees, then that's equals to Fk now, which is mu k times n. No? So that will be mu sub k times the normal force. Now if again, now Fk is mu times n. No? Now can you please no? So this is mu, which is 0.12, no? And then n, which is equals to 600. No? So so this is one set of our equation. No? Is there other forces that are on the horizontal axis? I think there's none. No. Now we could not directly say that n this time and w are equal because there's another force here, no, a T sub y that is now no, affecting the value of the normal force. No. Now if we'll try to get the value of the normal force for the vertical equation, so from the vertical forces, then n there no, is equal to w no, minus ty. No? So if you transfer w to the right side, it becomes positive. If you transfer this positive t sub y to the right side, it becomes negative. No? So to get our n, no? Then that is equals to w, which is 600, minus t sub y, no? Which is t sine of 30 degrees. No? So again, what is sine of 30 degrees? No? Sine of 30 degrees actually is what? 600. Sine 30 is 0.5, no? 0.5 of t, no? And again, now this is our equation now for our variable n, no? So n is equals to this value, 600 minus 0.5 of t. While again, no, tx is t cosine 30 degrees. Now, guys, can you solve for cosine 30 degrees, no? Kaya ang sine 30 is 0.5 mo, no? Can you solve for me in cosine 30 degrees? No? How much is cosine 30, please?
0.87, sir.
So this is now 0.87, no? T. No? So nadula na ni ang cosine 30, kaya mo na ning equivalent. Yeah. And now we will write mu, no? Mu being 0.12. No? Ang mu ko nga 0.12, i-multiply natin sa n, and we know n to be 600, no? Minus 0.5t. Okay, then we'll do the product there, no? We will distribute, no? So we'll stay with this as 0.87t. Now, how much is 0.12 times 600? 70.
72.
So this is 72. 0.12 times 0.5. That's equal to how much? 0.06.
Sir.
0.06, no? T. So therefore, if we have variables nga t, then we can combine them to the left side, no? So we'll transfer 0.06t to the left. And we will now have no, 0.87t plus 0.06 t, no? And this is equals to 72, no? So if we add together 0.87 with 0.06, no? How much is that?
0.93.
0.93 t, no? Equal to 72. So therefore T, the tension now is 72 divided by, no, 0.93. No? So pila atong tension?
77.42.
77.42 N. No? Okay, so that will now be our equation eventually. No? So this is the problem. No? So how much tension will we apply so that this will be pulled, no, with uniform speed? Then we divide this whole thing by, those that are in terms of the horizontal and the vertical forces. No? Okay, so any question from you? So this is with regards to, no, our, no, example 2. No? Okay, now going back, no? So we have this one earlier. No? So let's check. No? So our answer is 77.75. No? So again, this is kind of shortcut way, of solving, but again, you can split the forces here in terms of those that are on the x and on the y axis. Okay, so moving on. No? So I think this is the last slide. No? So do you have a question, by the way?
Sir, pila ka decimals ang kwaon?
You can use always 2 decimal places. No?